let's start the next topic, that is optimal system operation, which is also called economic operation. As I have told you in last lecture while introducing this topic, that there are hundreds, thousands of load flow, and we are not interested in all of them, because in real life, in practical life, we want the best load flow. Now, best means what? It is a subjective thing, as I have been telling you always. Is it from economy point of view, security, that is reliability? Is it pollution, that is emission? Now, are there only thermal plants, or is it a combination of hydro and thermal, or is it a combination of thermal, hydro, nuclear? Let me tell you, as far as modeling is concerned, nuclear is same as thermal. In fact, that is also called thermal plant. Thermal means what? Anywhere steam is produced. Now, whether you burn coal, whether you burn natural gas, whether you burn petrol or LPG or waste or nuclear fuel, that is uranium, plutonium, thorium. The whole idea is to convert water into steam, and once steam is created, that steam can be passed to turbine and then through generator power is produced. So, hydrothermal nuclear is same as hydrothermal. What is unit commitment? That is a very important problem, normally not done even in postgraduate studies. I will explain you what is unit commitment as we go ahead in this chapter. What is maintenance? As I have been telling you, in India we do not have maintenance culture. We hardly maintain anything, including ourselves. As I told you, we do not want to walk, we want to take a lift. Even youngsters like you are waiting on the road for 10 minutes to get a car and to get in. In that 10 minutes you can as well reach the classes. But that is a human tendency. Hierarchical problems, these all problems are hierarchical or multi-level. The control people should be knowing better what is a multi-level control, what is a hierarchical control. You have to follow certain steps. As doctor comes to see you, he first checks your pulse and then blood pressure, then if necessary the other other tests. Similarly, here the first problem which a power system control engineer, let me put it, addresses is load forecasting. Load forecasting is a very important problem even in control system, even in energy system. Unless until you know the requirement, even in daily life, the housewife has to be told how many people are going to come for dinner. Unless until you tell her how she will prepare the food for how many persons. So, requirement is nothing but a load. So, load has to be first ascertained, forecasted well in advance. Now, load forecasting is a separate chapter. In fact, if you want, you can read the chapter. I do not think we will be able to cover it in this class. Let us see how much time is available. You can have a short, very short term load forecasting. Next 10 minutes, how the load is going to change. As you can see nowadays in TV, all the time live temperatures come. Gone are the era when only one news used to be there, 9 o'clock news, and only 4 mega cities temperatures used to come. Not so long ago on Doordarshan. Now they tell you the temperatures of many cities all the time. So, very short term load forecasting, tomorrow, that is 29th of September, what will be the load? After a week, month, year, after 5 years, 10 years, you may ask me a question, why do you need to know what will be load in 2012? Today is just 2004, 8 years hence. Why I am saying 2012? That finishes the 5th, there is a 5-year plan, the 12th 5-year plan. So, that is why I said that year 2012, because in case you need a power plant in 2012, you have to start planning right now, because the gestation period For a hydropower plant is 7 to 8 years, that is the time we have, and even in thermal power plant you have some 5 to 6 years of gestation period. Gestation period is the time required before a megawatt is produced from a power plant, from the time it is conceived, it is planned, it is decided, the government orders are obtained, okay, you can go ahead with a power plant. And that is why it is needed long term planning, very long term planning, to decide the initiation of the installation of new power plants, because you have to decide which place, which site, which fuel, from where you are going to get resources. Is it World Bank, is it non-resident Indians, foreign direct investment, or it is a private party. Nowadays Reliance is busy in opening power plants in UP, Ambani's. So you have to decide. Even we are going to have a power plant in IIT, 12 megawatt. Maybe by the time you finish your PhD, it will start, in case you join PhD, or when you come here after 2-3 years. 12 megawatt, that is the gas fired. The USSR, former USSR, giving us some jet engines, Mirage engines, which are useless to them, but then you can produce power out of those. And Indraprastha, the gas company, is willing to give us gas at a reasonable rate. I don't want to use subsidized, because subsidy is a dirty word in reforms. You can't, that is why they are reducing subsidy every year. The gas price is already 350, yet there is a subsidy. So how long government is supposed to give you? For example, your studies here are subsidized by MHRD. The actual expenses come per student is much more than the fees that you pay. So your education is subsidized by taxpayers' money. Anyway, so that's why we need load forecasting, and that is our first multi-level is load forecasting problem. Load forecasting. Once load forecasting is known, then you should know what are the power plants that you have which are going to supply this particular load. Then out of these power plants, each power plant has certain number of units. Like Badarpur has 5 units, 200 megawatt 3 units and 100 megawatt 2 units. So out of these units, let us say for Delhi you have Badarpur, you have Indraprastha, you have Rajghat, and then you get power from NREB. Now which of these units, whichever is in your boundary, only you can worry about that. NREB is not a Delhi sort of a state business, it is whole of North India. Now which units will be on maintenance? You have to decide, because as I said, maintenance is very important. In fact, it is necessary by law that a boiler should be maintained once in 3 years, otherwise your license is not renewed. So it is mandatory, it is a legal requirement. So those units which are on maintenance, obviously they are not available to participate in power generation. If you are on leave, you can't attend this class. If you are busy elsewhere, you can't attend this class. That means the people who are not outside will be inside. So those units which are on maintenance cannot participate in producing power. So this decision will be taken at this level. After that, we have to solve unit commitment problem. What is unit commitment problem? Out of available units, which units will be on and which units will be off? 1, 0. Available, not available. Why you want to put them on and off status? We may not need all units. See, if you have your money in the bank, say 5,000, that does not mean you should go to ATM and get all 5,000 out. You don't need it. Why should you get 5,000 out? It depends on your need. So you may withdraw 100 rupees, you may withdraw 500 rupees, depending on need. Just because you have 20 units in Badarpur, Indraprastha and Rajghat, that doesn't mean you should ask all the 20 units to generate power. You may not need it. So unit commitment problems tells you for a given load which units will be on and which units should be off. How it tells you, that's the solution of unit commitment problem. I am not going to discuss it today. I will discuss it when the time comes. Once you know the number of units which are available and which can be loaded, the next problem is how much each unit should be loaded. That is called ED problem. Should it be, suppose it is a 100 megawatt unit, should you load it to fully 100 megawatt or 50 megawatt or 10 megawatt or any other number, depending on the need, depending on some objective function, economy, reliability, security, emission, voltage control, etc., etc. This ED will give you which unit which are available and you are willing to take load, how much load they will carry. That solution will come from ED. So you can see that the whole power system control problem is a hierarchical one or hierarchical one, the way you pronounce, or multi-level, 1, 2, 3, 4, 5 levels, and this is the final solution. Then you know, the operator knows which units will be on, unit number 1, 13, 39, and how much they will share the load, 5 megawatt, 50 megawatt, 100 megawatt, depending on the need. So this is the solution of the problem. Let us consider economic dispatch problem. In some literature, in some authors, some experts call it load scheduling problem. Either you pronounce as scheduling or scheduling, both are same. Americans pronounce it schedule, we pronounce schedule. So load scheduling problem or economic dispatch problem is, the general problem is to minimize the cost of power generation. Everybody is worried about the bill he has to pay every month or alternate months to DESU earlier, now then DVB, now it is BSES, okay, the private power company, which bill comes to you. You may not know it because in bulk the institute pays for hostels, but individually when you get settled in life, you may have to pay this bill, and this bill is now quite substantial. There was a time this bill used to be 30 rupees, 40 rupees, now it is 3,000, 4,000, 5,000, almost equivalent to salary of somebody, clerk. Why it is so high? Because reforms, power reforms, now it is a realistic bill, earlier it was highly subsidized. So you have to be very careful, and that is why energy conversion and energy management become quite important, because you should not unnecessarily pay the money for energy which can be saved. What is this equation? Minimization of sigma of Ci of Pgi. What is Ci? Cost of ith unit for generation of real power Pg at by same ith unit, and sigma is on all, I is for all generators, subject to, this is a load balance equation. We have to generate only this much power. The total sigma, total power generation should be equal to total load plus losses. Losses can also be considered as a load. If you are a BCom, a commerce student or management student, then whatever money is not coming, they say it is miscellaneous expenses. It is a loss to the company. However, it is an expense, because that money is not with you, it is gone. So this loss is no doubt not a useful way of using power generation, All the same, there is a technical loss, there is a theft in the system, there is a leakage in the system, that is all losses. So, this equation must be satisfied subject to is a constraint, it is an equality constraint. Now, we are talking about thermal power plants only. Why not hydro? Hydro hardly has any cost, because the fuel used is water, which is free almost. What is best load flow solution? It can be subject to reliability, subject to, I have been repeating this point again and again, cost is need not be the only factor, it depends on you, but general public only understands cost because they have to pay money at the end of every month or at the end of two months. Optimal operation of generators, optimization of cost. Cost function, operating cost consists of what? Fuel cost, labor cost, maintenance cost. After all, there are guys working in power plant. You have to pay salary, you have to pay their bonus, you have to pay their LTC. So, all this cost gets added to fuel cost, and maintenance is also cost. When you go to garage for your repair of your two-wheeler or four-wheeler, you do not have three-wheeler anyway, unless until there is some one of the student who is physically challenged, then there is a special, our Professor Gadgil comes in that three-wheeler. So, otherwise a normal person, you need either a two-wheeler or a four-wheeler. Well, you go for a garage for maintenance, it is not free unless until it is the first three coupons when you purchase a vehicle, then you get those things, that is courtesy or complimentary. But normally any maintenance, any repair will cost you money. So, that also has to be included into operating cost. So, in fact, what we are minimizing here is a total operating cost. Fuel cost is a major factor there. Now, that means I must know fuel cost curve, input output curve, input energy rate. What is my fuel? My coal comes from where? Is it Zaria? Is it Chandrapur? Is it Assam or is it Australia? We import brown coal from Australia, and you will be surprised to note sometimes that works out to be cheaper than using Bihar / Jharkhand coal from Zaria or Dhanbad. So, we also import the Australian brown coal and use it for power generation. Let us see what is this input output business. Here is the curve I have drawn. The x axis is megawatt generated, y axis is input energy in million kilocalorie per hour, that is a rate. Per hour means anything per hour is rate. Earlier we used to use BTU units, British thermal units, but now we use IS units or MKS units, which is million of kilocalorie per hour. If you do not understand this, you convert this into rupees and use fuel cost rupees per hour, which everybody understands. Once you say rupees, everybody understands what is rupees or dollars, pounds, euros, depending on which country's problem you are solving. If you read American books like Algard and Stevenson and Bergen, all these will give you examples in dollars per hour, but that does not matter. Why there are two limits shown here, megawatt min and megawatt max, and within this range there is a solid curve, beyond this and below this is a dotted curve. Any generator you take, if it is operating, it has to operate at certain minimum generation, otherwise what is the point in starting that generator? If you are going in a car or on a two-wheeler, you have to go certain minimum speed. You can't make it less than that, otherwise it will be highly fuel inefficient. I have seen many people while talking to somebody, their two-wheeler is already on. They don't want to, because they don't want to use kick again. No physical activity they don't want to do. Otherwise, they are just don't think that since two-wheeler is not going ahead, it's not consuming the fuel. It is consuming. Similarly, you cannot have a generator on and yet no power generation, zero power generation, because then why you have to keep it on? Unless until it is used as a spinning reserve or hot reserve. That is, as soon as some unit fails, you switch on that load to this unit. That is a separate thing. These are called standby generator or spinning reserve or hot reserve or whatever. If it is off, it is a cold reserve. That means the car is in the garage. You have to open the garage, you have to open the car, and nowadays 2-3 locks. So it takes time. And you bring out of the garage, and then if it is cold, it needs some time to start. So it's called cold startup time. Another is hot startup time. The startup time will vary depending on the state in which the unit is, and if it is you are so lazy that even coal is lying at the station, then you have to go to this station, from that goods train you have to bring the coal, then you have to put it in the pulverizer unit, you have to pulverize it, then it will come to the boiler. So God knows how much time it will take. Even it may be technically infeasible to generate slightly less than a particular number. Forget about economy. Similarly, maximum, if it is a 100 megawatt unit, you can't generate 500 megawatt, otherwise it is a miracle. Nobody will purchase a bigger size units. If you can go to, for some time, yes, you can have a 125% rating, you can work, but not all the time. So you may go slightly more than the rated value, but not for all time to come. Otherwise, you are changing the rating. Don't call it a 100 megawatt unit, call it 120 megawatt unit, if you are able to generate all the time 120 megawatt. So that is why there are two limits. Now, how do you get this curve? By performing experiment. What sort of experiment you perform? You put a coal, burn it, see what is its steam output, and then how much power output you got, and you get certain points as usual when you do your experiment, and then you pass a curve in your laboratory experiments, which you might have done in your undergraduate as well as postgraduate. Some people draw the curve first and then draw the points. That's a separate issue. We are not going to discuss this in this class. So we assume that you have drawn the points first and then draw a curve later. This is called curve fitting technique. Now in literature, numerical analysis course, there are chapters on curve fitting techniques. Now there are various techniques which can be used. Least square fit is the best. Now this is the equation: cost of power generation at ith unit, generating power is PGI, and if you feel that you can fit a quadratic curve here, then this is the equation. Now it is a model of the curve: AI BI PGI plus CI PGI squared. Here is also C, here is C. If you feel you get confused, you can make it D, so that there is no confusion. Otherwise, this C is a small c, this C is a capital C. But if you feel that you can get confused or your handwriting is bad, teacher may not understand, use D here. Luckily, there are 26 alphabets in English language. What is this AI? This is this one. The intercept on y axis is AI. That means this much cost you have to give or incur even if you generate zero power. There is a maintenance cost, there is a labor cost, and even to keep running the generator at no load, you need steam. So you must have done no load test. no load losses. Why there should be losses at no load? Because the transformer or a generator or a motor does work, does run no load speed. In fact, no load speed is the highest speed. As soon as the load speed drops, whichever motor it is, as you can see in your house, if you have started one lamp, if you start another lamp gets dimmer, because you are loading the system by putting on another lamp. Hence, this is AI and this is the cost when PGI is 0. Then you have BIPG. This is obviously a equation of second order curve, quadratic equation. What is incremental fuel cost? Incremental fuel cost is very important term, that if you add delta X in generation, what is the increase in fuel cost? That is incremental, del C by del PG or dC by dPg. So, I take a first order derivative, I take a partial derivative, partial differential equations. You might have read Gorakh Prasad book or any Prasad book, or the complete total differential equation, full differential equation, dCi over dPgi. Partial can be converted to full differential. Why? Because the cost at Panipat is nothing to do with Sonipat. So, partial differentiation can be made full differentiation, and this is equal to AI constant 0, this is BI and this is 2 CI PGI rupees per megawatt hour. If this is a quadratic, obviously this becomes a linear, one order lower, and hence this curve I have plotted in the next slide. If it is the exact, it will be a non-linear, because your original equation is not quadratic, you are making it to be quadratic. It can be cubic, it can be any order depending on a particular power plant. Similarly, here if it is not quadratic, the first order less will also be non-linear, but if it is quadratic, this will be a linear curve. Again, we are interested in drawing this linear curve between these 2 points, megawatt minimum and megawatt maximum. I already explained you in detail what is minimum limit and what is maximum limit. So, this is a figure drawn for incremental fuel cost. Some people call it IC curve, incremental cost curve. If you want to draw this curve in a reverse form, so PGI is equal to alpha I plus beta I IC dash I plus gamma I IC I whole square plus so on in megawatt. Now, I am coming to optimal operation. So far, any problem? Now, I am going to apply optimization technique. I want to optimize my operation. I am considering a particular station, let us say Badarpur, and how many units are there? Okay, unit and generator are used interchangeably. Actually, unit means what? Boiler plus turbine plus generator is called unit, a generating unit. All three together is called unit. Fine. Let us assume there are k units in Badarpur. So, the equation to be minimized is capital C cost is equal to sigma I is equal to 1 to k Ci Pgi, subject to, again you have seen the megawatt minimum, megawatt maximum. Pgi has to vary between Pgi min and Pgi max. I now do not have to explain this constraint equation. This is inequality constraint. The load balance equation was equality constraint and this is inequality constraint. Here this balance equation is no losses, because you are only considering Badarpur. There is no transmission, no transmission losses. So, sigma of PGI must be equal to load which is coming on Badarpur. Who will give this value of PD? Load dispatch center. I requested you to go and visit load dispatch center across the road on Kathwara Sarai, and that is worth visiting. If you do not visit, your MTech in power system or even in control system is of no value, because all controllers are there, all control systems are working, and they are working beautifully. So, tell your coordinators or your whatever, you go there and take a letter, fix up an appointment and have a 2-hour visit fix. It is so near, it should not be a case of so near and yet so far. Kindly make it before you leave this campus. So, you must visit that load dispatch center in Kathwara Sarai. Now, what is method of Lagrange multipliers? This method was proposed by two gentlemen called Cohen and Tucker. You will be wondering why nowhere in the literature any Ram, Sham, Govinda appear. They don't, Indians don't work. Have you ever, except Raman effect in physics or Jagdish Chandra Basu's that effect that even the trees etc. have life, that he proved. Have you, and few more, have you ever read anywhere that Ghanshyam Prasad equation or some particular theorem? I do not know what we are doing. Olympics 000, but for some Rathod 1 silver. Earlier some Leander Pace 1 bronze in 96, 2000 some Maleshwari or somebody, some weightlifting. It is really shame, a country of what, 1000 million, 1 billion and no medal, only cricket, that is useless game, waste of time. Only 8 fools play that, and you get 50 lakh for playing such a game. Anyway, I do not think that is the subject matter of this topic. So, Cohen Tucker were two gentlemen who presented this paper in 1953 conference, and they say what you do, you form a Lagrangian. This C bar can also be written like this. You need not write C bar, because that again gets confused with this C. So, it is better to write this. Lagrangian is similar to pound sterling without that dash here. If you put dash here, it becomes a pound sterling. So, it is not pound sterling, it is Lagrangian. And how do you define this? The original cost function, which is C, minus Lagrangian multiplier times the equality constraint. This is equality constraint. This I can also write as same thing. So, this is the equation I have written here. Lambda is called Lagrangian multiplier. This lambda has again 4 names in literature. Control system people should know: adjoint variable, co-state variable, Lagrange variable. I do not know whether you have read this. Have you done optimal control? So, you must have done this. You know, sitting quiet. You also done it somewhere, optimization technique. So, this is Lagrange multiplier. Cohen-Tucker condition says that this Lagrangian with respect to all, then I have to give here x u p function of, had some heavy breakfast today? Heavy breakfast, sleeping. So, what is x, what is u and what is p? X is a state variable, or in literature it is also called dependent variable. like you are dependent on your parents. That is why you remain a dependent up to 18. After 18 you may revolt and you say I am independent today onwards. In fact, in foreign countries, in western countries, when you become 21 there is some celebration. That means you have been liberated. This u and p together are called y, independent variable, right, which can be controlled. But I have no money, no intention to control everybody. So, I control only a subset of y, which is divided u and p. So, u is a control subvector and p is a constant or disturbance variable. I do not want to touch this p, I assume it to be constant. And you can make it more and more complicated, stochastic, white noise, color noise and so on and so forth. These control people must have studied that. As far as I am concerned, p is a constant. I am not going to touch it, I am not going to control them. That is why I divided x, u, p. So, the Cohen-Tucker conditions are Lagrangian with respect to x should be 0, Lagrangian with respect to u should be 0, Lagrangian with respect to p should be 0. These three together are called KT conditions, and the details about this is given in appendix E in the book. In case you get more interested, read it. You should cultivate the habit of reading books, journals, because you are a postgraduate student, you are not undergraduate. So, that even cows essay nursery boy or girl also writes, and people do PhD on cow also. So, you might have done this topic in undergraduate, but here you have to do it in a different way, different style. So, you should read what is this Cohen-Tucker conditions, what was the original paper of Cohen-Tucker, it is given in this particular appendix. Read it, understand it, and that is what value addition. Here unfortunately or fortunately, here we only one variable Pg. So, that is u, control. You have to control power generation. How do you control? By varying the steam input. So, only one derivative put equal to 0, and if you solve this you get this solution. The next step you get a solution. It is such a simple problem. Del Ci by del Pgi minus lambda 1, from here it will get 1. So, minus lambda can be shifted to right hand side, you get this as equation for all k. This is CTM, CTM is commit to memory. You can expand this equation into this, del C1 dC1 upon dPg1 is equal to dC2 upon dPg2 is equal to dCk upon dPgk is equal to lambda, and this is called equal incremental cost. This is incremental cost. All such incremental costs, when they are equal, we say we have achieved economic operation. These equations are also called coordination equation in literature. Suppose I give you a question, derive coordination equation for economic operation, then this is the equation you have to derive. I think today we will stop here. Any problems, any difficulties so far? Anything you want to ask? No? Then we will finish today.